Setting up coordinate proofs. This is actually a very quick assignment, but this is practice in putting coordinates instead of numbers on ordered pairs. We do this sometimes in geometry. It's called analytic geometry. We use coordinates that are variables in order to prove things, like we might plug them into the distance formula or the midpoint formula. Let's give this a try. So all you're doing here is giving the ordered pairs for each point. Given that KD is length M and that segment KJ is R. So let's start up at the top on the left at J. Notice that X is 0. You don't go left or right at all. You're on the y-axis. X is 0. So this ordered pair is 0, comma, and the distance up right here is R. That would be the y value. 0, R is your point for J. Let's do D on the lower right. The distance X is M, and I don't go up at all, so it's M0. And so the coordinates of D are M, comma, 0. Make sure you use parentheses when you enter the ordered pair. H is the same X as point D, so it's also M. That's that far from the y-axis. And the distance up is the same as point J, it's R. So point H has coordinates M, comma, R. Here's that same basic rectangle, but it's turned. Same idea. Point N in the top left is 0 for X because we're on the y-axis. The distance up, in this case, is D. Point F has an X value right here of T, and the Y value is 0. Point K has an X of T also, just like point F, and a Y of D, just like point N. So N is 0D, K is TD, and F is T, comma, 0. This is a right triangle in the coordinate plane. It has one point where the right angle is at the origin. So when we have 2 points to find here, that's point C and A. Point A has an X of 0 because it's on the y-axis. And the distance up to A is J, so 0, J are my coordinates. Point C, the distance to C is W, that's your X, and the distance up is 0, W, comma, 0. This one's interesting. Notice they called the distance to point E and point Y 2E and 2C. The reason for that is it makes much nicer coordinates for F, point F. So let's start with E in the top left. It's on the y-axis, so X is 0. The distance up is 2E, Y is 2E. Y has an X value of 2C and a Y value of 0. Now to find F, F is the midpoint of EY. Remember the midpoint formula? The midpoint is the average of the x's, x1 plus x2 divided by 2, and the average of the y's, y1 plus y2 divided by 2. So we're looking at these coordinates right here. The midpoint, point F, would be 0 plus 2c divided by 2, and 2e plus 0 divided by 2. We average the x coordinates and we average the y coordinates. Well, 0 plus 2c is 2c divided by 2 is c. And 2e plus 0 divided by 2 would be 2e divided by 2 would be e. The coordinates of point F are C, comma, E. Here we have a parallelogram. The opposite sides are parallel. When you have a quadrilateral with opposite sides parallel, that's a parallelogram by definition. We're going to talk about that soon. Notice the 45-degree angle there. This angle here is also 45 because it's a corresponding angle. Remember, you have parallel lines and you have the angles on that same side of the parallel lines and on the same side of the transversal. So we know those angles are 45. Now, if we subtract from 180, we can find this angle right here. 180 minus the 90 in the corner minus the 45. Well, that ends up being 45. So this angle up here is 45, and this angle here is 45. Notice the triangles of 45, 45, 90. It's got two equal angles. That makes it isosceles. This one and this one are equal, and that one are equal. And in fact, we know that the two triangles are congruent because parallel lines are the same distance apart. So that means this one and this one are equal. And we got a 90 and a 45 angle side angle of both triangles. These two triangles are the same triangle, in other words. Now, the distance right here is h. That means this distance here is also h. It's isosceles. So point E would be the distance C right there plus the h. C plus h, that's your x distance. And your y distance would be this distance right here, which is w. So w. And point W, we got a lowercase w and a capital W. I mean, that they're different. Keep in mind, points are named with capital letters. Constants are usually lowercase letters, usually, not always. So point W right here would have an x of c and a y of 0. So the coordinates of E are c plus the h and the y of w. And the coordinates of point W are c, comma, 0. This last one's a trapezoid. And just like the last one, see the 45 in the quarter? These are isosceles, 45, 45, 90, 45, 45, 90. And just like the last one, we know that parallel lines, see the parallel lines, are the same distance apart. So that means these two are equal. And just like the last one, we've got the right angle in the corner, and we got the 45 at the top. It's angle, side angle. Those two triangles, again, are congruent. We can see that point H has an x of E and a y of 0. Point B, the trick is to realize this distance is t, and that means that this distance here is also t, because those two triangles are the same triangle. They're flipped around though. That means point B is this distance, E, minus the t, because we have to go back to point B, minus that distance of t. And the distance up to B is sitting right there. It's the h. It's the y of point P. So the coordinates of point B are E minus t, comma, h. And the coordinates of point H are E, comma, 0.